To verify the stress distribution over a rod after it is exposed to torsional load, I will be performing a small FEA analysis. I will use Abaqus CAE for this simulation. At first, I will go to the part module and create a sketch. Here, I draw a circle of a radius 5 mm and extrude it up to 100 mm. Then I will go to the property module, create steel material by specifying its density, Young's modulus and Poisson's ratio. Please note I am using tons as a unit for mass and mm as a unit for length. After that, we created a solid section and selected steel material. I have applied this solid section to the created geometry. In the next module called assembly, I selected the created part and added it to the assembly. In the step module, I created a general static structural step and named it as a torsion. In the incrementation tab, I changed the initial increment size to 0.1, which means in the beginning of the simulation, it will only take 10% of the total load. Before going to the interaction module, I will create two reference points at the centers of the rod faces. Now we can go to the interaction module and then constraint manager to create couplings at the both ends of the rod. One end of the rod I will keep fixed while other end we will apply the moment. So I will create a kinematic coupling at the fixed end and distributing coupling at the other end. In the load module, I will apply a moment of 1000 Newton millimeter at the center of the distributing coupling. And will apply the Ancaster boundary condition at the center of the kinematic coupling. This boundary condition will constrain the coupling in all degrees of freedom. The next step is meshing, also called as discretization. First, I will apply the global seed size of 2 mm, then we will go to the element type and keep it linear and uncheck the reduce integration, as I don't need the hourglass control here. In mesh controls, keep it hex and medial axis. Then go to the mesh part and say yes, the part will be meshed. In verify mesh, you can check the element quality. I will skip this step for this exercise. Now our model is ready, we just have to run the simulation. For that, go to the job module, create a job, give it a name. I will name it as a torsion and submit the job. For visualizing the results, I am using Meta from Beta CAE as a post processor. After plotting the von Mises stress results, you can see that at the center of the rod, the stress value is close to 0, while it is maximum on the nodes that are on the circumference or on the outer surface. So we can state that when a shaft is submitted to twisting when a torsional load acts upon it, the stress produced in it will be maximum at the outer surface and 0 at the center of the rod.